So welcome to my next talk, which is on remote access and business partners, or business partner connection in the IPv6 world. And actually this talk was kind of born, or you will see this when we go through it, from a number of case studies. Organizations where we ran into different types of problems, or especially in the later part when it comes to business partner connections, a number of heavy debates. As it turns out, it's not that easy, especially those two areas. Remote access and business partners have their very own specific sets of problems and issues when it comes to IPv6, and that is the actual basis of this talk. There have been voices in the last maybe 10, 15 years which were about like, wait a second, once IPv6 is there, and some of you might recall that in the early specifications there was a mandatory requirement, IPv6 must have an integrated IPsec stack. Funnily, even though the development of IPv6 or the specification in IPsec was seemingly independent, the whole IPsec thing started mostly in parallel to IPv6 and then was backported to IPv4 when you look at the RFCs and the numbers and stuff. So there was this hope with IPv6, we will have IPsec anyway, and then it cures all, combine IPsec anyway plus global addressing. What's the need for VPN solutions or for any type of additional encryption on top of this anyway? Which is why I will very quickly comment on where do we stand when it comes to IPsec in the IPv6 world. Then I'll discuss remote access, where remote access usually means, say, the road warrior scenario. Your organization operates gateways, and there is people traveling or working from home or doing whatever, being in your guest Wi-Fi, connecting to these gateways to get access to corporate resources, which is a specific, say, use case and specific area which can be distinguished from the area of the dedicated, say, segment-to-segment business partner connections, and we will discuss a specific type of those later on. These are the three parts. Let's have a very quick look at IPsec. IPsec in itself, well, hasn't been the biggest success story of the IP world. Those of you having been involved in running and operating IPsec-based infrastructures, especially when it came to heterogeneous devices involved, know that this has been a nightmare. I myself, actually there is a paper I wrote in 2000 about heterogeneous IPsec in certain, like Cisco plus connecting to Windows and stuff like this. And that was for many years one of the most downloaded papers we ever had. I had, there were situations in my life, I even once missed going to, my wife is in humanities, and somewhere in like 2002 or so, she got tickets for how do you say a premiere im Theater for like Faust or something, an important piece, and she got premiere tickets, and this was a huge event. And on the same day, I was in at the time I was living in Heidelberg, which is why ERNW and Troopers is in Heidelberg. And on that day, I was working in Düsseldorf and setting up a VPN connection. Actually, it was planned Monday and Tuesday. Tuesday night was this planned visit of the theater. Monday, Tuesday was meant to set up certain VPN devices for a customer. Monday evening, pretty much everything worked. But then again, it was like, well, it was planned to be there 2 days, and to have a look at, well, to deliver a certain state. So we decided, okay, in the next morning we will document everything, and then after that we will leave. Tuesday morning, 9 o'clock, things were running smoothly, at the time it was with Cisco. I don't even think it was ASAs. This was still Cisco PICs. And there was the CIO of that organization showed up. Well, no, the head of network. It wasn't the CIO, but that guy, I got along with him very well, and he was like, "Oh, beautiful! It's already working. So essentially, you can leave." What about, he had an interest in technical stuff, like explaining the config and the setup to me. So I went through the config and the setup with him, and there was this parameter where he was asking, what is this? And I was like, well, actually, we don't need this. And on Cisco, like, no, something. And immediately the tunnel broke. And I was like, oh, fuck, shit. Cursor up, like bash control, I do the automatically, it's control, what you jump to the beginning of the line, control A, isn't it? Yes. And remove the no. Those two, like 10 seconds later, config voice. I had the same state as before, but the tunnel didn't come up again. The whole day spent on troubleshooting. I did not manage to get it working again. Exactly the same stuff. And actually, it was like, okay, to be in Heidelberg at 7, to go to the theater, I have to leave from Düsseldorf. I should leave at 3. It could work if I leave at 4. I left 10 minutes past 4. I was at home at like 8:30. I mean, A4 in the afternoon. Those guys from the Rhineland, I don't have to tell you. Anyhow, it was one of the... my wife was not amused, to put it mildly. This is my memories of setting up IPsec in the early days. Very briefly, nowadays we have IKE, at the time it was IKE v1, now we have IKE v2. IKE v2 is much easier, has much less parameters, much less phases during the key exchange and stuff. So one can really have the hope that IPsec becomes easier nowadays. And we did some lab testing. There is a number of documents out there. Actually, IPsec has become easier nowadays than it has been like 10 years before. So having the hope, okay, we might not even need any like VPN technology, as there will be integrated IPsec. This hope might fulfill in some time. Point is, first, there is a it's not mandatory. It's an informational RFC 6434 node requirements for IPv6 systems, like which functionalities all IPv6 systems have to mandatorily support. There is in the interim there is a should. I mean, it's a capital should, RFC 2119. So should means, well, it's nearly a must, but the strict requirement that every node which speaks IPv6 actually has an IPsec stack. This strict requirement doesn't exist any longer, and you can expect that there will be devices, especially those with limited processing power and a limited number of gates and stuff, that there will be systems which don't have IPsec. Overall, in the long run, relying on IPsec being there anyway to solve certain security challenges might be a viable strategy. Still, we usually right now recommend to our customers, wait a second, don't rely on this integrated IPsec. Gain operational experience first, and then maybe in 3, 5, 8 years you can think about like having all systems, talking to all systems IPsec, which then removes the need for dedicated remote or dedicated, say, VPN solutions. That's pretty much all what I want to say about IPsec. I would say it's not yet in production state in IPv6. Which brings us to the say, second part, remote access. Scenario, run in VPN gateways and have road warriors connect to that, either over IPsec or over SSL. This is in a surprisingly, or maybe not surprisingly, high number of organizations, some of those even represented here in the room, considered one of the most important use cases for IPv6, for the simple reason that in Germany, as some of you might know, we have a quite significant deployment of cable networks. In cable networks, the most common transition strategy is going with DS Lite, the dual stack Lite, which in turn has several technical implications, one of which is it usually breaks IPsec, and in some cases it even breaks SSL VPN. So this means the more people working at home have V6 there, the higher the chance that they can't actually connect to the corporate at the time V4 only VPN gateway as a DS Lite, the transition technology chosen by the provider breaks this, which again is in 2 of 30 German DAX organizations, in at least 2 which I personally know, enabling, bringing IPv6 to the VPN gateways is considered the first and foremost. This is the first thing we have to do. We need this. The thing is, and as I mentioned, most of the slides actually from this talk, I have taken them from customer case studies, or I put together put stuff I had documented anyway onto slides. It's not that easy. It turns out that once you want to do so, like imagine your organization is at a point you have done your homework in the sense of you've got address space from the registrars or from your provider. You have done an address plan, you have maybe are involved in network, some test things, you are involved in planning activities, and now it becomes real. The first thing you want to do is enable IPv6 on the VPN gateways. Let's imagine that specific situation. And this is what actually happened to me 3 months ago. A customer where I had been involved in the planning exercises 2.5 years ago, they called me and there had been, they hadn't done any IPv6 activities for about 1 year, given due to a new tendering process for worldwide network and security provider services, one of these regular tenders, which happen in some organizations. And now they called me okay, we want to enable IPv6 on our VPN gateways now in 3 main regions, EMEA, APEC, and Americas. Which addresses, given you have been involved in our address planning 2 years ago, can we quickly discuss which addresses to use? And I was like, oh, wait a second. It's not that easy. There is a number of things you have to maybe clarify first. These things are on this slide. say the actual addressing approach, route propagation approach. These two are not necessarily like VPN specific. You must do these steps at some point anyway. It's just once VPN gateway is your first actual use case, you must take these decisions in the course of this exercise. The other two or three are actually more VPN specific, in the sense here is one has to discuss or to come up with decisions related to VPN technology. Let's go through these in a second. There is a thing, the addressing approach. The background of this one in quite a few organizations is there have been debates. Again, this is not so much VPN specific or remote access specific. That's why I will cover this very quickly. But still, experience shows this type of discussions often happen in the context of the VPN use case. The thing is, organizations have discussed, okay, if we want to use global addresses, are we supposed to go with, and we are a multinational organization working in globally, operating globally, should we take or apply for addresses at the, imagine the organization is headquartered in Europe, just at the RIPE NCC, or are we supposed to get addresses from the other registrars, namely ARIN and APNIC, or maybe even LACNIC in Latin America and AFRINIC as well? Quite a few organizations have decided to be on a safe side, to apply for address space from the other registrars too. There is some specific things which have to be kept in mind. Actually, I have done this for many organizations, so I'm, if you're interested, if you think about this, feel free to approach me over lunch or dinner. I can tell you a bit about this. But even if you have done so, let's imagine, and in this specific case, this was actually the situation, you have this address space from several registrars, or at least the most common case is ARIN, RIPE, NCC, and APNIC. Now, when it becomes real, use this address space, actually, say 3 VPN gateway clusters in 3 regions. Take American addresses for the one located, say, in Texas. Take APNIC address space for the one, say, in Singapore, and take one for, say, Frankfurt. Or go with, try to go with address space, say, just from RIPE NCC and propagate routes, say, European routes. But this European route concept is a bit, that's a strange concept anyway, as the internet is supposed to be global. Still, on the routing and the provider level, there might be some things to keep in mind. Go with consistent address space from one registrar, or go with, say, split multiple address space from multiple registrars. That is one debate that has to be a discussion or decision has to be taken anyway at some point in an organization. In this specific case, it turned out, okay, VPN gateways were the actual occasion where the decision had to be taken. There is, just to lay this out, there is the multiple address space approach. There is this what we call the cohesive address space approach. Both have their advantages and disadvantages. We actually, the most common recommendation that we give is get address space, at least from ARIN, RIPE NCC, and APNIC, depending, say, for a typical multinational organization. Get the address space, but try on the actual operations and implementation level, start with a cohesive approach. So just take, try to go with RIPE addresses only and monitor the situation, which is exactly what happened in this specific organization. That's what was decided. We'll go with, we'll only take the RIPE addresses and we try to propagate them even in in Singapore and in the US. For several reasons. I won't discuss this in much detail. One thing that should be kept in mind here, going back one slide, is this thing, geo-IP location. That can become very, very tricky once you go with address space from one registrar only. If, say, your business model relies on being able to identify customers or partners based on geo-IP location, be very, very careful. There is some, actually this can be done. I will probably write a blog post about this in the next, say, weeks. There is certain lists, there is organizations which run the geo-IP location databases, and you can actually interact with these databases, but I can tell you, like a case study, I had a discussion with the guy, with Marcus Keen from Microsoft, who has done the IPv6, he's kind of the lead of the IPv6 initiative at Microsoft. And last week I met him, and he told me, I know we have decided for this approach. We initially had this one. And you might know, those guys of you are familiar with like what Cisco usually recommends. And if you've been at Cisco Live, you might be aware. Cisco goes with this advice, cohesive, one. Whereas Microsoft goes with this one. And the main reason he gave me was geo-IP location. That was the main reasoning why Microsoft, according to Marcus, changed from one. I hope this is public information, but I assume it is from one approach to the other. Then once this has been decided, and we in this specific use case we came up, okay, we go with the VPN cluster, gateway of clusters, cluster of gateways in APAC, EMEA, and Americas. They all get addresses from the RIPE allocation. Next question was, okay, what about the routing propagation strategy? Propagate like huge chunks, or only propagate like /48s, where the actual VPN gateways are located. I mentioned this discussion yesterday. Just very quickly, in this organization, while the overall strategy is in the long term to go with a null routing approach. That means propagate the full space, but identify specific internal networks which must never be reachable, like the prefix with the loopback addresses, and black hole or null route those at the network borders. This is the intended strategy. Still, we decided, okay, if it's only for the VPN gateways right now, let's try. Let's see what happens to gain experience and to find out what is the maturity of the main providers. It's actually mostly two involved when it comes to propagating /48s. Again, you can read a bit about the advantages and disadvantages of these approaches, both on the slides, and I've given additional links. And again, this had to be decided in the context of the VPN gateways, as this was the first main use case. But those two are not specific to VPN. The next question that came up was, wait a second, what are we going to use the VPN gateways, and which is even in that organization different technologies. There is some Cisco-based stuff. There is some Juniper, no longer Juniper Pulse-based stuff. Do we want to use this just for road warriors, or do we want to use this for like connecting business partners? And we will see that there are some things to be kept in mind. It's not so easy like, okay, we use this for both groups of them. And the second thing to decide is, what does actually mean enabling IPv6 on a VPN gateway? Does this mean transport, like I can reach the specific box or cluster, whatever, by means of IPv6? Or does it mean I can use IPv6 within the tunnel as well? As going with IPv6 within the tunnel would immediately require additional actions, like okay, what does it mean? Which address prefixes to like distribute to the tunnel? Where do those get routed? Which systems are then accessible? What about DNS and all this? In this specific organization, it was decided, well, we want to be reachable over v6, but we do not yet offer v6 through the tunnel, which is, again, I would say, from those organizations that we know and we have been involved, that's the most common approach. That's what we see most often. Thing is, there is a specific, and I wouldn't say it's well known, but it's, I've seen this in different contexts, in different environments, problems related or in the somewhat similar to this one. There is a kind of well-known bug of a number of Cisco AnyConnect versions, which was one of the technologies used in that specific one, but I would be very surprised if not here in the room. From statistics point of view, I would assume on quite some of the systems I see here there's an AnyConnect client running, including mine, for access to specific customers. With AnyConnect, once you have the situation that the client within this local environment has IPv6, and again, in Germany, we have like, I think it's 22% of users which actually have IPv6. In Belgium, it's, what do we have, 41 something? Well, then there's Switzerland, but in the US, it's like 22 as well. So there's large economies, including Belgium, of course, having high degree of V6 deployments for the user, for the actual broadband and the telco space. So now imagine there is a system sitting in a local network which is V6 enabled. This system establishes over V6 a tunnel. Within the tunnel, only V4 is provided, and a certain approach is taken that is a split tunnel approach. So it is assumed that the user actually forwards all the traffic into the tunnel. It's not able to have non-tunnel connection in parallel. In that case, many versions of AnyConnect kind of misbehave, that they do not, for V6 traffic, they do not use the DNS server provided as part of the tunnel setup, but they use the local DNS server, part of their local IPv6 environment, which, as you can easily imagine, means reaching resources within the corporate network via DNS becomes impossible. Or probably becomes impossible. Not sure if in public DNS you have your corporate resources. And actually we stumbled across this in two environments, and I know from Ivan that he has seen this, and not sure, Johannes Weber is not here in the room. He wrote even a blog post about similar problems. This depends on the, it can be cured. We have one customer which runs AnyConnect in this version. They don't see this type of problems, and they have pretty much this exact setup. So it depends on the AnyConnect version. The thing is, this is, I wouldn't even say this is Cisco specific. The point is, be aware that it might be confusing, like for systems, to reach out via V6 to a VPN gateway, and then having V4 only in the established tunnel. This well, it depends on the maturity of the stacks actually involved. And so this is, I wouldn't say this is Cisco specific, but keep this in mind when you think about enabling remote access. It's not an easy, okay, just enable v6 transport to the gateway. Another thing, this again is not too much VPN specific, still it popped up in the, it was an interesting discussion we had. Well, now that we have VPN gateways in that specific organization, the VPN gateways were sitting in network segments right behind the internet border gateways, but before the first layer of firewalls. We won't discuss if this is good design or not. I'm aware that quite some organizations do it this way, and I see no reasons why not to do it. The thing is, then they were like, okay, we give the VPN gateways, we configure them with static addresses. What about the default route? Configure that in a static way, or learn it from the actual internet, from the border gateways, as the devices were called in that organization, and I mean that's a common term. By means of route advertisements, learn the HSRP address of the border gateway cluster. Or do it in a, and once you do this, that you distribute just the default route, no addressing information. You must clear the PIO, prefix information option, in the route advertisements. This should be clear. The thing is, now they were like, wait, if we do this, there are reasons to go with a static approach. Actually, in this organization, they, as we will see, decided to go with static address configuration, but learning the default route by means of route advertisements. The question was, okay, if we just do this for the VPN gateways, and now the routers start to emit router advertisements, which they hadn't done before on their internal interfaces. What does this mean for the other devices in the same segment? Is there any side effects we have on the firewalls sitting in those segments? Or maybe, as I said, there is different types of VPN gateways. There might be other systems located in those segments. What happens if those systems receive route advertisements? Those systems are presumed to be v4 only still. And what does it mean for firewall logs? Even if you have v4 only and you constantly receive route advertisements over v6, will this show up in logging? Does this have, again, any side effects? This was an interesting area of discussion. In the end of the day, they decided, let's go with the route advertisement approach, and I think that was a good decision. I mean, I was one of those guys at the table actually recommending this and acting in favor of this. But this essentially means, wait a second, have a close look once we enable the route advertisements on the internal interfaces of the border gateways. What does this mean for all the other systems located in the same segment? And actually, we decided, okay, let's. That organization, fortunately, has a reasonably well-equipped test lab where the main components, at least, not in latest versions, but the main components are present. We decided to go to the lab. This is 6 weeks ago. I don't know if this has yet happened, but I think I would know if there were any issues. That I'm pretty much sure I would have received a mail like, oh, I know we stumbled across this or that. So all these, including, I will very quickly cover this, including okay, once we go with static addressing, which approach to choose, there is different approaches. There is the one that is used in this organization is depicted here, and the one that is used for actual devices within a segment is on this slide. This is organization specific, but these are good approaches anyway. To summarize this, it turned out that enabling IPv6 on the VPN gateways had a number of, meant we had to take a number of decisions, both VPN-specific ones, like handling of the tunnel and handling of the tunnel configuration, and maybe this thing, router advertisements for the ASAs and Pulse devices or not. We came up, again, this is a bit case study specific still. I left the slide here as I think it might be of use for some of you to have a little checklist. Okay, what things to look at, or what were the actual steps that we, once we had taken the decisions on the list, what are the next things we had to do. Now let's look at the other main part, which is business partner connections. The background here is, and again, this is based on a case study, this time from another organization, so it's not the same as the one that I used in the first part. This organization where the discussion happened, which I'm going to lay out in the next slides, is actually it's in the automotive industry sector. And one specific thing of the automotive industry sector, but this exists as well in manufacturing, and to some degree this exists in like chemical. In certain industry sectors with very deep and complex supply chain structures, it's common that that organizations within this industry sector connect to each other by means of somewhat semi-closed shared networks. For example, in Europe, there is the ENX, European Network Exchange, for automotive organizations, which has several hundred, say, organizations connected there, all the main suppliers, of course, all the main auto manufacturers, and this is operated by like an organization, this ENX. There is an equivalent to this we have customers in the US doing stuff over the ANX, the American Network Exchange, and there is like the Maschinenbauer and such organizations. This is not too uncommon to have this specific types of networks. So they have business partner connections. The technical properties are they have more or less direct connections. Of course, there might be traffic filtering, but it's not going through the internet. It's not like traditional DMZ terminated IPsec tunnel stuff, but it's more like somewhat shared networks. Usually MPLS is involved to a high degree with somewhat direct connections. Now the thing is, right now in the V4 world, in those types of networks, or in these types of connections, there is, in pretty much all cases, at some point there is NAT involved, for the simple fact that, well, all these organizations use RFC, well, most of them, RFC 1918 space in their internal networks, which would clash. And NAT is, at least NAT in the N-to-1, in what was called in the earlier days masquerading. So several addresses are translated to one address on the other side of a gateway. This flavor doesn't exist in IPv6 anymore, at least not in the standardized way. There are devices which can do that. We have another customer, in that case, using the FortiGate devices, which actually do this in well, I have to say, high performance, very stable. I mean, from an IPv6 purist perspective, we don't like this, but they do this, and they were like, okay, let's do mostly what we have done before in V4 and the same architectural approach in V6. But you can't really, I mean, this is implementation specific, so this was probably not what you want to do with in a heterogeneous environment with different partners. And the other new kind of paradigm shift or new thing with V6 is that global addresses are going to be used within the corporate networks instead of at least some of those, say the majority, not all, but the majority have used 10-something space in the past. This brings some interesting questions, as this might mean, okay, first of all, a certain thing that we have used, N2 NUT, is no longer available, and it might not even be needed, as we have distinct global addresses in both sites anyway. So we can get rid of the NUT. But then immediately a question comes up, oh, wait a second. If we, and I can cite this as public information, Bernhard Huber from BMW, we have not been involved there, so any case study I discuss has nothing to do with BMW, but he gave a presentation at Cisco Live on their IPv6 efforts. A very interesting presentation, by the way. Is that one public? Do you know, Eric? I mean, most of you have been at Cisco Live, or quite some in the room that I know anyway. So once you have an account, you can access the stuff. That was a really interesting presentation, and in the course of that one, he said, like we are partnering in such a way. He didn't mention the technologies, but we have like 1,000 business partners. So now think about it. Once you have some connection with a 3-digit number of business partners, and all have their own global addresses, and you have some more or less direct network connections, do we want to carry the routes of our partners within our own routing tables? That is one of the first and foremost questions that comes up. With NAT, everything is hidden. You don't see the routes of the partners. Now with globals, that could be different. On the other hand, question would be, I'll just come back to this in a second, what else could we do? And before an actual decision was taken on a strategy, we went back a step and we said, okay, let's define, say, objectives. Whatever approach we choose, let's discuss objectives first, which could be of relevance in such a scenario. One objective we identified was, say, manageability of routing and routing protocols within the own network. Probably most of you will agree, being involved those of you involved in network operations or routing operations, you don't really want to have a high number of external routes in your own routing processes on your network gear. So that could be an objective, like to keep this number of external routes small. Then there is a thing that we call stability of the overall routing system. Let's assume we accept external routes from the partners into our own routing domain. Does this mean we can become transit network at some point? Their internet traffic going through our network as routing, something has gone wrong. And a number of other points. Actually, I will discuss any of those very quickly in a slide. That one I've already mentioned. Do we want to carry external routes on within our say routing domain, within our corporate network? Actually, this somewhat in many organizations this can somewhat be seen, but usually it's a very small number of routes. What happens if this suddenly becomes a higher number of routes? What is the impact on the routing recalculations? What is the impact on performance? What is the impact on manageability? Like looking at a router table and being able to identify own networks versus like where a packet actually goes just by looking at it. I would say many people, or put it differently, who of you in the room thinks that it's a good idea to have a 3-digit number of external routes in your own routing domain. Who of you doesn't like the idea at all? Well, I see a high end here. This confirms what we have seen in discussions. So, well, let's take this as one decision contribution argument in mind. The second one is somewhat related. This is what I call the manageability of routing protocol. No, that is once you come up to the conclusion, well, it might be okay to carry external routes. For whatever reason, it's maybe the least painful alternative, and we will see all of the alternatives are painful. In this space, there is no easy solution. So much I can say right now. The thing is, okay, now let's assume we accept external routes. By which means do we do so? Do we actually get in a routing exchange? In the worst case, over an IGP, over like OSPF? Do we just do it over BGP? Do we get the routing information and configure it in a static manner on our way and redistribute? So at least we have some control what ends up there, some human interaction, some human verification. And funnily enough, Ivan yesterday in a blog post he wrote this one: don't ever run OSPF with a third party, even if it's your friend, kind of, which goes along nicely. That I would say, and I have a background in operations and actually in routing operations as well. I wouldn't like the idea of accepting external routing information over an IGP, namely OSPF. I wouldn't like that at all. Even if it was like, say, not so stubby areas. I really get goosebumps just thinking about this. Well, it's one step of a decision which you have to take. Then there is this, what I call the overall stability of the routing system. How can we avoid that either we become transit, in the worst case, for the other organization? Or, I mean, this transit scenario, this will probably at some point, at least on your own border gateways, will be stopped. I hope it will be stopped and it will fail there. But the more interesting scenarios, what about, say, we have connections to two sites of one business partner? How do you avoid we become transit for their intra-site traffic? Say, let's assume they have a problem within their company internal MPLS network, and it turns out to be a huge problem, but we still have the links, they still have the links running up to your organization. What happens then? I mean, there is still a routing path. But it goes through your organization having multiple interconnects with the other organization. This is probably not what you want to do, carry their traffic in your network. Another thing might be a route leakage. How do we avoid that? I mean, the stuff is usually then it's bidirectional. How do we avoid that routes, either their routes leak some from our network or our routes leak from their network? These are things to be kept in mind. One of the objectives was like, okay, whatever approach we opt for, does this support our overall routing security? The thing with the just announced specific prefixes, or more importantly, more interaction can be like thought of once we have this null routing approach. What does this mean on a business partner interconnect? Do we handle this differently there? As maybe we don't want specific segments to be reachable from the internet, but our, say, R&D department should be reachable like from joint venture with a business partner and systems sitting on their side. So how well do those get along? Another one would be assume that within our network we filter traffic by means of ACL on layer 3 interconnect points, wherever, somewhere in our network. Now if we have say, external networks showing up with their own prefixes, with their global prefixes. What does this mean for ACL configuration on our devices? It might be helpful as we can more easily identify which are, say, external routes versus NATed routes. But obviously it might say we have the situation at some interconnection point, traffic from certain business partners has to pass, like from those joint ventures where we hold 50%, but from others, which we consider less trustworthy, we don't want to pass the traffic. This will blow up ACLs. That might come into play. The same for, say, traceability, logging. Assume that all violations of, say, on devices within your network are fed into a SIEM or are even processed by means from a CSAT. How would those guys know which is actually an external versus an internal route? I mean, this can be done more or less easily, but how would they know? Okay, these here are strange packets here on some firewall protecting the R&D segments. We see failed attempts, and we have to find out, is this our supplier in Mexico, or is this our joint venture in China, or is this some plant in Hungary, whatever. Once you want to have this information at hand in real time, it means you have to be able to understand who do those routes belong to, or this, say, source addresses, which is easy as long as they show up with their real source addresses, which becomes much more difficult once you translate it on the path, which is, as we will see, an option, do translation. Translation means you don't see external stuff, makes ACLs easier, but translation would also mean they are hidden. You can't really, just looking at a prefix, it becomes much harder to identify is this China, Mexico, or Hungary. And to be able to process this information, you would need a mapping. But this mapping is kept in an Excel sheet at some. This is not accessible in real time to the CSAT at the time. All these are actual things that contribute to the discussion. One thing that could contribute is, like, say, I would say the political layer. How do you play with your business partners? Actually, in one of the organizations where we had this type of discussions, they are very, very large organizations. Actually, one of the largest European players in their field. And one of the guys brought up the idea, well, we could just hand out, we could take a chunk of our address space, slice this into a number of /48s, and each business partner gets a /48. And they have to use these addresses once they want to connect to us. And they were like, okay, I mean, with IPv6, systems can have several addresses. And so they can, well, Eric is nodding, multiple interface, it's not a multiple interface scenario, but source address selection could come into play, and so they have systems over there in their organization. They have multiple addresses. As long as they communicate within the organization, they take one address, and once they connect to our organization, they take another address. Why shouldn't this work? We heavily recommended against this, as we said, wait, technically, address selection is a major pain in itself. It doesn't work reliably. And the other thing is, really, you want to, even though if you're usually, when two partners sit at the table, you are the kind of like bigger partner, you want to induce to them, they should use addresses you get from your side, We have seen this failing in the past, like in the banking organizations, and they had the same approaches, like Reuters at some time and stuff. This won't work out for many reasons, and especially this won't work out in a scenario where you have a new supplier relationship or joint venture, whatever, and then the network people show up. Hey guys, our managers just signed a deal. Here's the addresses to use. And the other guys are like, wait, okay, we will do this, but it takes 2 or 3 months to get this configured, routing wise and stuff. What is going to happen? I can tell you, as I was involved in this, there will be management escalation. Wait a second, 3 months? We just signed the deal. We want to have their data in our SAP next week. 3 months delay for forcing them to use our addresses? This is unacceptable. We will find another way. So this one won't work out. But still, it's a thing to consider. How do you want to treat your partners? And of course, there is this overall, say, operational feasibility. What does, would some approach mean in my specific organization from an operations level? How many devices do I have where I would have to carry external routes? How many, like going back to this one, how many devices do I actually have where I use ACLs? If I don't have any, you can ignore this one. If you don't have, if you have many, you must consider this and in this part. And so after defining these criteria, we identified, okay, in the end of the day, there's 3 potential approaches. The first one, and these approaches can be distinguished according to which source address will show up in my network. It can be the business partner is allowed arrives with their own addresses, with their global addresses. Okay, klar, sorry. So they use their own addresses, which can be translated at gateways or not. So it's processed within my organization as an external route. Second one would be that it actually was the second one. The first one was, according to this, I mean, it's you can order them in any way. I repeat in the way they are on the slide. They show up in my network with an address, with a prefix from my address space. Either because beforehand I've handed this out and forced them to do so, or whatever they do, it will be translated at the say interconnection point between their network and our network. The second, they show up with their source addresses within my network. They are routed. Third one, agree on, say, some independent prefix or some independent like network to be used for this. There is people actually in one of the organizations which are connected to the ENX, to the European Network Exchange. They were like, oh, we don't really care about this. We won't be involved in this discussion as we expect ENX to solve this. So far, it has been done by some like services combined with certain gateway technologies, including NAT. And in the future, well, let's wait what ENX proposes as a future service for IPv6. We won't get into this discussion right now. So these are the main potential variants. And actually, in that specific organization, in the end of the day, one decided to go with, or this is the current proposal. The final decision is still not taken, and there are still ongoing discussions, and we are not happy with this. There might be something better, but Right now, what's on the table is going with an NPTv6-based approach. NPTv6 is, well, a translation technology within the v6 space. So it's against the, some people might say it's against the core principles, and it's a sin in itself to think about such a thing in the v6 world. We do actually think, I as a person, I think this is pretty much the only viable use case I've so far identified for NPTv6. And funnily enough, I will get back, but there has been Fred Baker, who is the kind of inventor of NPTv6. He wrote an internet draft back in 2007, business-to-business private routing, about this exact thing. And the solution he suggested at the time is, looks pretty much like NPTv6. So I think this is actually a valid use case for this specific technology, even though wearing my IPv6 purists hat, I don't like the idea of translation, not too much. But again, for this use case, it might be a viable path. What technically happens at NPTv6? It's so-called stateless algorithmic translation of prefixes. So addresses, packets come into a device on a, like, just change the prefix, so the interface identifier stays the same. You don't have to keep state. The prefix part, the first 64-bit, are exchanged to another prefix, and then they continue. They are forwarded. Usually it's a /48 into /48. That's, I would say, it's a technology not yet widely deployed, but this will probably be the most common case of use. It's much less disruptive than NAT4.4, given you don't have to keep state, and but still, you might see the same type of problems that you have seen with NAT4.4 in the early ages. Whenever there's protocols carrying address information in the payload, this might break some stuff. It's too early to really judge on this. Still, looking at the availability, in that case, most firewalls support it nowadays. The thing is, at these types of interconnects, there's not necessarily just traditional firewall settings. In that specific organizations, it's mostly ASR1s, say, used in that part of the network. On the ASR1s, a guy from Cisco, actually, I had an exchange with somebody involved on the Cisco side, and who should know. And I asked that guy, and he was like, right, he wrote in October, we plan to have it in XE 3.17. It's not there in XE 3.17. I've looked, and there's a 3.17. Actually, there's a 1S in the interim. It's not there either. But as I noted, it's in NPTv6 is supported in iOS since 15.5.3, something like 4 weeks or so ago. Do you have a question or comment?
Yeah, I'm just thinking about what is the benefit of this? Because compared to the operational overhead, for me it's even more overhead compared to the use case I use a prefix designed by one of the.
Yeah, I will answer this. Let me postpone the question for like 1 minute.
Okay.
I just wanted to introduce what, given I discussed the technical variants earlier on, what would be the actual technology used in an approach involving translation. And so we were like, okay, we have objectives, we have criteria, we have potential approaches. Now, obviously the question was like, what do you guys from ENW recommend in our situation? And again, this was one of the it was a lot of intellectual energy was spent on this one. That was a really tough one. We had a number of discussions and back and forth, and we could do, we don't like this. Well, what are the alternatives? And so on. The main, I will give a more detailed answer on the next slide, but the main reasons why this proposal was the one left on the table was we don't want to have external prefixes in our organization. We don't want to see on our routing tables and our MPLS backbone anything, pretty much anything else except for our, say, prefix space. Or we can't force the other guys to use our addresses. And all the alternatives, we don't like any of them, but this is the one probably with the least possible associated pain. I'll get back to this in a second. This is essentially a very rough diagram laying it out. What we came up is like this table looking at the objectives and assigning like a degree of like fulfillment on a scale 1 to 5. 5 means very high is implemented in a very good way, kind of. So, for example, once no translation happens, it will be very easy to identify, say, who is acting, which is not the case once translation comes into play. We lose visibility, but from a management perspective, when it comes to external routes, when it comes to applying, where is the ACL thing? Applying ACLs on these ones is considered cumbersome and tedious. So overall, in this organization, and I don't display the slide for to give you a final recommendation how. In case you have similar discussions and issues. This is not meant to be a final recommendation, but this is meant to provide a basis how to approach the task at all. Keep these things in mind, and then maybe come up with something, adding points, whatever. I mean, this is not rocket science. This is pretty much very basic stuff for decision taking. The main thing here is what are the points to keep in mind. Eric, you had a comment. Yep.
So for me, as a security person, it's variable. Now, if you end up, of course, with 1 million crowds in your IGP, then you have a problem. And of course, you do not need to peer with OSPF with them.
Yeah, that is pretty much, that was kind of, I mean, we had this included for completeness sake, but everybody on the table, not only in this organization, was immediately, no, we don't want this. Not use an IGP. Maybe think about BGP, as BGP always involves human intervention, which then adds this, say, review and verification element. But yeah. As you might have noted earlier, most people don't want to see to have external routes in their own routing domain. Even though, from a identify who is like a friend or foe, kind of. Of course, you would never call a business partner a foe, but from that angle, actually, yeah, traceability, high points. But overall, we came up in that specific environment while taking the specifics of the environment into account. This is the least painful way probably to go.
And NPP also ensure that the traffic is symmetric. So
yeah.
If you have any kind of stateful device, you have two connections to your partner.
Yeah.
Always connect to the same one.
Yeah, and it actually reduces, given this symmetry, it reduces less, say, potential of becoming transit and leakage, as it's pretty much clear traffic of this, say, prefixes is going routed in that way, and not going up to our border gateways. That was one element as well in the overall decision-taking process. So that's pretty much it from my side. I have the slide. Once you go with such an approach, what are additional things to keep in mind? Of course, like DNS is your friend. Use as few as possible addresses, actually, in any type of connections. NPT has to be supported. Integration with IPAM, well, that could help to have like a database where you could do the lookup. On the process level, documentation, going with an NPT-based approach, that is crucial. To be able to identify, oh, wait a second, if the guys from the CSAT see this prefix, which business partner is that? And this, you have to maintain that, I wouldn't say manually, but that has to be part of the workflow, but, the thing with the workflow is for connecting business partners, I've yet to see a very mature workflow when it comes to this, even in those organizations with like hundreds or thousands of them. And of course, you should periodically review the mappings. Is this still needed? Do we still have this joint venture? Do we still have this business relationship? As otherwise, packets might turn up in your network that you don't want to see there. Summarizing this, as I mentioned, in particular in Germany, remote access in the VPN sense is a common, one of the first use cases for actually enabling IPv6. Keep in mind there are some decisions that you have to take beforehand. It's not like, oh, just enable and we are good. There's side effects. And in the second part, I covered business partner connections, which have, especially the type of business partner connections I was discussing, have their own peculiarities. And the thing is, there is no easy solution for this one. That is, I don't know any organization of this type who have found a solution they are happy with. They either postpone this, as this organization I mentioned, like ENX must solve this, or they are like, it's not good what we have here. It's the least painful thing. That's it from my side. Thank you for listening. I'm open for questions now. Okay. Martin.
Solve this like technical solution direction.
Yeah.
So if you're talking to a supplier in Hungary, his factory might be next week in Bulgaria. What do you do? So the trust model doesn't change. The geography does change. Maybe technology changes, but the business problem stays the same.
Yeah, I mean this is a whole area in itself. I could. We have once, let me see if I can quickly find this. I mean, this is probably not of too much. Let's put it like this. There's like evaluating trust of a connection, like a business partner connection. It's an interesting area in itself. We have once developed in a very large organization as well, rating scheme with a number of questions. What type of connection is this? Where do they come from? Which type of data classification do they access? Blah, 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 blah. Like 25 questions with a rating scheme. And the output of this one is certain categories, which then are assigned controls. Like, okay, we for like bucket number 5, we need good logging and one-stage firewall plus contractual controls. Versus for bucket number 1, like those joint venture stuff, we might need some packet filtering implement, might be a firewall or a thing, but we don't. So different set of controls. I can show this. I don't think I can quickly find it on my local. I've done this. If any of you is interested, approach me and we will have like at 5 p.m. Have a joint look at this. I can show you the scheme, and I mean it's our intellectual property. We developed it, so I'm willing to share it. It's not bound by any NDAs. And there, this would go into the equation. Like if they move from like Hungary to Bulgaria, say that could be. Actually, there is one. One question in the scheme is where is the source of? Is that located? And given the environment where we developed this, there are 3 answers to this, which is Europe, Luxembourg, or outside Europe, for the simple reason that it was an organization heavily involved in Luxembourg, and they trust each other. There's traffic that is supposed to stay on Luxembourg soil, whatever happens. So from that angle, moving Hungary to Bulgaria would not change anything, but moving from Hungary to China would give a different point rating. And this could mean, oh wait, we have so far done it with this type of technology, we must add something. Any other questions? Then I think seriously, I went over time so much. No, it was we were supposed to 45. Okay, excellent. Then enjoy lunch and see you later for the actual workshop parts. I mean, there's different workshops going on. Enjoy lunch and see you later.